Assalamu alaikum students, your instructor Abdul Rafi here for A-level mathematics. So today this is our going to be first lecture on Poisson distribution, and everyone needs to understand, just like we have the binomial distribution and normal distribution in the statistics 1 S1 of 9709 A-level mathematics, we have Poisson distribution, that is S2, the first chapter of this statistics 2. Okay, so what is Poisson distribution and when can we apply Poisson distribution? The first thing is, it is again a discrete random variable. Okay, so it's basically a discrete data. It takes into account the discrete random variable as well. And secondly, in order to apply Poisson distribution, I'm going to give you examples as well. There need to be, if X is set to follow Poisson distribution, if the events, whatever the event is occurring, it should have four things. Okay, it should be independent, it should be single event, it should be random, as well as it should have a constant average rate as well. Okay, so let's write it down, these all 4 points. Okay, so I'll repeat it again. If X needs to follow a Poisson distribution, the event needs to occur independently. It should not be with other events as well. I'll explain you that with examples as well. It should be independent, as well as the event should be single, not more than one event is happening together. Okay, there cannot be two events happening colliding together. The event should be random, it should not be biased. Okay, there should be not biasness as well. And the last one, the most important, that it should have a constant average rate, also called lambda in our case. Okay, so it will be constant average rate as well. These are the four things that need to happen for the event to occur and X to follow a Poisson distribution. Okay, so very important, these 4 points are. Then the next thing is, if we look at some examples, you will understand this better chapter. Okay, so the examples are, let's say that we can say the examples are that number of cars arriving at a petrol station. So you're going to say that number of cars arriving at a petrol station in 10 minutes. Okay, so number of cars arriving at petrol station in 10 minutes. So here we go. In Poisson distribution, you have a time duration as well. You will be given at a given interval time of space. Okay, there is an event going on, that how many cars are arriving at the petrol station in 10 minutes. So this event is independent. We are not looking at traffic jams, we are not looking at how many cars are stopping. It's the event is independent, the event is single as well, only one event happening. The event is random as well, because we are taking any cars, how many cars, and we're saying a constant average rate. So whatever the rate is for 10 minutes, we are going to have that. Okay, so this is one example, number of cars arriving at a petrol station in 10 minutes. So we need to understand that X follows a Poisson distribution. Its parameter is mean, which is also called lambda. I'm going to write down that as well. So we have X follows a Poisson distribution. That's how you write. X follows Poisson distribution where there is lambda. Okay, and this is basically called the mean as well. Okay, so it's the only parameter that Poisson distribution have. We also call that constant average rate. We need to understand that. Basically, this is how we are going to solve questions on that. Let's look at other examples as well. You can give another example as well, such as number of planes landing at an airport in 30 minutes. Okay, so number of planes landing at the airfield, okay, in 30 minutes. Again, you are not discriminating against, or you're not choosing amongst the number of airplanes. It's the event is happening random, it's independent, and there's a constant average rate, because you are taking how much time, 30 minutes. Okay, so students need to understand that this is basically, whenever you have to solve an Poisson distribution question, you will have to have a given interval of space or time, and we'll find out how many cars are coming, what is the probability of the occurrence of the events. Okay, so we'll have to find out what is the probability of the occurrence of the event as well. So let me give you more examples as well. Number of emergency calls that is received by an ambulance in 1 hour. Number of goals that are scored in a football match in 90 minutes. Let's say number of bacteria in pond water for some millimeter. Okay, so these are all examples of Poisson distribution that students need to understand, and the event should be single, random, constant average rate. So Poisson distribution is appropriate for the number of accidents in an year, but it might, if there is biasness, let's say the biasness is that you are considering the traffic jam as well, you are considering families or friends, then it is not, the event is not random, or the event is not random, and the event is not independent as well, because you are applying biases and the event is dependent on the family and other things as well. So hope students get it, that when you can use the Poisson distribution as a model, and what is the formula, that X follows Poisson distribution, that is the mean. And what is the actual working for this? It will be probability of, if you have to find probability of X is equals to X, that is basically, let's say probability of X is equals to 3, how many cars passing arriving at petrol station in 10 minutes. So the formula is that you have E minus the lambda into lambda power of the X value divided by the X factorial. Okay, so that is the original formula, and you will only take the integer values, that is 1, 0, 1, 2, 3, 4, 5. Decimal values are not taken in the Poisson distribution because it is a discrete random variable. Okay, it's the discrete data, so you take only discrete values, that is 1, 2, 3, 4, 5, 6 to infinity you can take, and that is the main formula. Okay, students will get better when I'm going to solve question. So let's look at some past paper questions, basic examples from 2019, so everyone understand how we are going to work this out and what different types of questions you should expect in the past paper exams. Okay students. Okay students, so we have question number 24. As I said that we are going to discuss a lot of 2019 past papers for Poisson distribution, and I'm going to give you all the concepts. So this is basic concept, the basic type of questions that you are going to face in the Poisson distribution in the exams. Okay, so this is for 1 mark, and it's 2019 May June, paper 7-2. Now definitely the paper is changed to paper 6. The random variable X has the Poisson distribution 5. So this means that you have X is equal, X follows a Poisson distribution, that is the mean is 5 or the lambda is 5. Okay, so you can say that, sir, the lambda is 5, and you have to find the probability of X is equals to 2. That is what will be the probability when the value comes as 2. Okay, so it's going to be very simple, as we know that the formula is E minus the lambda multiply by lambda power X divided by X factorial, as we have discussed in the previous lecture as well, that e power minus lambda power X into X factorial. So we are going to apply that, and we are going to get the answer, that is e power minus 5 multiply by 5 power 2 divided by 2 factorial. So here we are going to get the answer. Make sure to have a calculator and give your answer to 3 decimal places or 3 significant figures as well. So here we go. I'm getting this as 0.0842. Okay, so I'm going to do it for 3 significant figures. Students, the answer is coming as 0.0842. Hope everyone got this basic understanding of the question, how to apply. Okay, this is just to start off things. Let's talk about another question. This is the answer for this. Okay, and the reason I'm doing past papers is better, you'll get a better idea. Similarly, we have another question, that is question number 23 of May June 2019, paper 7-1. And as I mentioned again that now it is paper 6. The random variable X has the distribution Poisson, that is 2.3. Okay, so what you're going to do always, it's a 2-mark question, and now here you have to find the probability between 2 and 4. Okay, again this is concept number 1, basic concept. Okay, so hope everyone is not making a mistake here and everyone is getting it. Okay, so it's going to be, again you write that X follows the Poisson distribution, sir, that is 2.3, and now you need to find the values, that probability of between 2 till 4. Okay, the X can get the value between 2 and 4, and 2 and 4 are inclusive, students. Okay, so follow very carefully, that you are going to say that we have to find, sir, the probability of X is equals to 2, 3 and 4. Okay, x will take up the values of 2, 3 and 4, so you'll have to find the probability for 2, 3 and 4. So how you're going to do it, students, follow very carefully. E power minus lambda, or the mean, into the lambda power of, you say, 2 divided by 2 factorial. This is one answer. Then you're going to do plus, this is one answer, and you're going to do e power negative 2.3 into 2.3 power of 3 divided by 3 factorial, because that's the formula, right? Let me write down formula again. E minus lambda, lambda power x divided by x factorial. That's the original formula, but I'm going to explain you how you can make it easy for you, okay, as well. So this is the next one, and then you're going to say that e power negative 2.3 into 2.3 lambda of 4 power and 4 factorial. Okay, so what we see as students here is that you can take this as a common. Okay, you can take e power lambda as common. So here we go, that's what you're going to do as well, and that's how normally we solve the question. E power negative 2.3, you can say that it will be 2.3 power square over 2 factorial plus 2.3 power cube divided by 3 factorial, and the last one will be plus 2.3 power 4 divided by 4 factorial. So you're going to add these and you're going to get your answer. Okay, so e power negative 2.3, make sure put it in the calculator, students. Okay, so 2.3 power square divided by 2 factorial plus 2.3 power of cube divided by 3 factorial plus 2.3 power. I'm putting in the calculator, students. Okay, hope everyone is getting it. Divide by 4 factorial. And here you go, I'm going to get the answer as 0.585. Again, all answers should be to 3 significant figures. Okay, so all answers should be equivalent to 3 significant figures or 3 decimal places. So here we go, 0.585 is the answer, and that is going to be an answer for 2 marks that we have solved. Hope students are getting how to do the concept number 1, the basic concept, that is finding out the probability of 2 and 4 between them, between the values, a single value as well, you can find out the probability. Let's discuss a bit more complicated question. Okay, that is question number 22. That is again from February March 2019. Again, this is basic concept. Okay, so very important to understand, everyone. Let's talk about it, and here we go. So the question says, students, that we have this time the number of eagles per hour in a certain, the number of eagles seen per hour in a certain location has the distribution Poisson 1.8. The number of vultures seen per hour in the same location has the independent distribution. So both of them are independent distribution. Your first part is that you have to find the probability for 2 marks that in a randomly chosen hour at least 2 eagles are seen. Okay, so the first thing is very important. This is the interval. Okay, in this question, students need to understand is the interval, and whenever the interval is same, it's very simple. Okay, we're going to do in the next video some questions where the interval will be different. Okay, so the number of eagles that are seen per hour in a certain location. So everyone needs to understand here you have to identify your x variable. Your x variable is basically, sir, x is equals to number of eagles, because you have to deal with eagles only, that are seen per hour. Okay, and if you want to write in a location, certain location, you can write, but number of eagles seen per hour is enough. So x follows then the Poisson distribution, that is 1.8 eagles. So they are basically saying on average lambda value or the mean value, on average 1.8 eagles are seen per hour. Okay, hope students are getting it, that on average this is where you can get the explanation that the number of eagles that are seen per hour. So for 1 hour you can see at least the average rate is 1.8 eagles per hour. Okay, and what do you have to find, students? You have to find, this is another type of question, at least 2 eagles are seen. So you have to find that at least 2 eagles are seen, which means at least means minimum, that at least you need 2 eagles to be seen, which means that it can be more than 2 as well. It will have to be minimum they need 2 eagles, but it can be more than 2 eagles, which means they can go to infinity, as we can have 2 eagles, 3 eagles, 4 eagles, 5 eagles, 6 eagles, and it will go on till infinity. So because you cannot find this probability directly, because it will take a lot of time and you will not be able to reach infinity, that is why you're going to say that you're going to subtract from 1 minus the probability of x is less than 2. Okay, so you are going to subtract the probability of from 1 minus the 2, more than 2 you need, so x is less than 2, you are going to subtract. Okay, what this means, students, that you need minimum 2 eagles, right? If you need minimum 2 eagles, which means you can go from 2, 3, 4 and upwards. So if you what is left, only 0 and 1 are left. So if you subtract the probability of 0 and 1, you are going to get the answers for them. Okay, so probability of x is equals to 0 and probability of x is equals to 1. If you can subtract, make sure don't include 2 in it, because 2 is part of your answer. Okay, at least 2 eagles means that 2 is part of your answer. So you need 1 minus the probability of x is equals to 0 and 1. So here we go, you can say that 1 minus, it will be e power the negative 1.8 lambda into basically multiply by 1.8 lambda power 0 divided by 0 factorial, and then you have to add e power negative 1.8 into 1.8 power 1 divided by 1 factorial as well. So a lot of students don't understand this. You can make it very easy and simplified form by saying that 1 minus, just take out the exponential e power minus the lambda common, and inside you are going to be left with 1, because anything to the power of 0, any number to the power of 0 is 1. So always remember the probability of x is equals to 0 will be 1. Okay, students, always remember the probability of x is equals to 0 will be 1, and the probability of x is equals to 1 will be also the lambda value. So if you see carefully here, that it will be the lambda value, because 1.8 power 1 is 1.8 divided by 1 factorial. 1 factorial will not affect anything, students. So here we go, so it will be e power negative 1.8 into 1 plus 1.8. So I'm going to get my answer, and let me write down the answer here for part 1. The answer is going to be, let's use the calculator here. Okay, 1 minus e power negative 1.8 into, you got 1 plus 1.8. Okay, so I'm getting it as 0.537. Okay, so this is the probability of at least having 2 eagles. Again, 3 significant figures, 0.537 is the answer, students. And this is the probability of seeing at least 2 eagles in an hour. Okay, minimum 2 eagles. You can see more than 2 eagles as well in this. Okay, hope students got this very important concept that I'm explaining here, that when you have at least, you have to go the opposite way. You have to subtract the probabilities that are not required from the 1, and you will get the answer. Okay, the important thing to understand is the less than 2, you are not going to find out the probability of 2 as well. Okay, you are going to only find out, students, the probability of 0 and 1. Hope everyone got this question as well. Let's discuss another example, students, on the Poisson distribution chapter from 2019 Topical Past Papers. This is now October, November or winter 2019, paper 7, variant 3. As you know, it's now become paper 6 in recent times. Okay, so understand this importance, that cars arriving, this question is basically talks about the unit interval. As I was speaking, that you have to change the lambda. Okay, you will have to change your lambda when the unit is different. Okay, so let's read the question and understand what they are saying. Okay, students, so here we go. Cars arriving at a filling station randomly and at a constant average rate of 2.4 per minute. After reading this line, you should be able to identify that x is equals to cars arriving, number of cars arriving at the gas station, number of cars arriving at the station. You have arriving at station in per minute, arriving at station per minute. Okay, you have per minute data available, students. Okay, and how you're going to write this data, sir? It's going to be x follows Poisson distribution, that is lambda value 2.4 per minute. Okay, so it's 2.4 per minute. Hope students got this. It's just the normal thing that x follows Poisson distribution. So in 1 minute, 2.4 cars are arriving at the filling station or the gas station, petrol station. 2.4 cars are arriving per minute at the gas station. What we have to find, let's read that now. So what we have to find, sir, is calculate the probability that fewer than 4 cars arrive in a 2-minute period. So there are two important things. First thing is there are fewer than 4 cars, and the other thing is that they are arriving in a 2-minute period. Okay, so the first thing will be changing your mean. Okay, so if in 1 minute it is taking 2.4 cars are arriving, so you need to change your Poisson distribution, students. X follows Poisson distribution. For 2 minutes you multiply, you take out the average, so it will be 2 into 2.4, it will be 4.8 for 2 minutes. Okay, hope everyone get it, that the lambda value, students, will be 4.8. And why is it will be 4.8 cars, the lambda value will be 4.8 cars. Hope students are getting it, that for 1 minute it is 2.4 cars on average that are arriving at the filling station. So for 2 minutes there will be 2 into 2.4, that will give us 4.8 cars arriving for a 2-minute period. Okay, so that is the lambda, that is the constant. And then you have to find probability of x is less than, fewer than 4 means less than 4. Okay students, fewer than 4 means, so this is again another concept, fewer than 4 means less than 4, so you'll have to don't include 4 in it. Okay, fewer than 4 means 4 is not in it, so you'll have to find the probability of 0, 1, 2 and 3. Okay, less probability of x is less than 4 means, students, that you have to find the probability of 0, 1, 2 and 3, and you're not going to find the probability for 4. Okay, so again you're going to say that e power negative lambda, so e power negative 4.8, and this time you just start directly. I'm going to take e negative 4.8 common. So as I mentioned in the previous lecture, for probability of 0 is always 1, probability of 1 is the lambda value, so 1 plus 4.8, this is 1 plus 4.8. Okay, hope everyone gets this. Okay, so it will be 4.8 power 1 divided by 1 factorial, so 4.8, and then it will be 4.8 power 2 divided by 2 factorial, and 4.8 power 3 divided by 3 factorial. Okay, so hope students got this. Let's see what's the answer coming. E power negative 4.8, 1 plus 4.8 plus 4.8 power square. You can do it in the normal method as well that you are doing. Okay, you can write the whole function as well, not a problem, but better to use the common and then do it. Okay, so I'm getting the answer as 0.294 to 3 significant figures, and that is the final answer as well, 0.294. It's correct as well, students. So hope everyone gets this, that how we are going to change the interval and how we have to solve questions like these from 1 minute to 2 minutes. So you can get more questions like this, students, as well, that it was 10 minutes, what will be for 30 minutes. Okay, half an hour, what will be for 5 hours. Okay, so this is basically a summary of concept number 1, where you can have probability of less than 4 as well. Okay, how to find the values of less than 4. Then you can also expect between, greater than, at least values as well. You can also expect between the values 2 and 4, that were 2, 3 and 4. Okay, you should also expect questions like this, and this will be your homework as well, that between 2, 3, this is 2 is included and 5 is not included, 5 have to be excluded. Okay, so you will only find the probability of 2, 3 and 4, students. Okay, probability of 2 till 5, so 2 is inclusive in this one and 5 is not inclusive. So hope everyone got this unit interval concept as well. Now we are going to move forward and discuss more Poisson distribution questions, what you can expect in the exam paper questions as well.